All right, welcome to another video where today I'll be looking at a relatively popular argument for the existence of a designer, the argument from cosmological fine-tuning. But before we begin, I'd like to thank everyone for subscribing. We recently hit 1,000 subscribers, which is great. Thanks so much. I would also like to thank the patrons, but I'll talk more about that at the end of the video. Anyway, cosmological fine-tuning. So while there are a variety of arguments that might be made from the sort of fine-tuning to the existence of a designer, for sake of time, I'm just going to focus on a Bayesian sort of argument of this sort. And it's a sort of argument that we could state roughly as follows. So premise one, given the non-design hypothesis that the universe wasn't designed, it is extraordinarily unlikely that the universe would be life permitting. Premise two, given the design hypothesis, it is not extraordinarily unlikely that the universe would be life permitting. Premise three, the non-design hypothesis is not antecedently extraordinarily more probable than the design hypothesis. Premise four, if for some hypotheses A, B, and data C, if the probability of C given A is extraordinarily low, the probability of C given B is not extraordinarily low, and the probability of A is not antecedently extraordinarily more probable than the probability of B, then the probability of B given C is greater than the probability of A given C. Therefore, conclusion 5, given that the universe is life permitting, the design hypothesis is more probable than the non-design hypothesis. Put this another way. The fact that the universe is life permitting is just overwhelmingly unlikely on the non-design hypothesis, but not so on the design hypothesis. I mean, it might be very likely, but it's at least not as unlikely. But since our prior on the design hypothesis is not significantly lower than for the non-design hypothesis, even if it's lower, it's not like so much lower that it will overwhelm the fine-tuning evidence. When we condition on the data, that is, that the universe is life permitting, we find that the design hypothesis is more probable than the alternative, than the non-design hypothesis. All right, so that's the basic sort of argument. Why would someone accept the first premise, one? Well, the idea is that the universe is fine-tuned for life. So put one way, of the many, perhaps infinite ways the universe could have been, the vast majority are not life permitting. So in support of this, it is often pointed out that varying the physical parameters of the universe, but even a minute amount, results in a universe which prohibits life. But those variations still seem to correspond to a way the universe could have been. Right? I mean, you raise the gravitational constant or the fine structure constant or a variety of other parameters, or lower them just a little bit relative to the overall range that these parameters consistently could take, and you produce, so to speak, a model for a universe which is not life permitting. Stuff flies apart. You don't get complex chemistry at all, or stuff collapses nearly instantaneously, and similarly, you don't get complex structures, let alone anything lifelike. For more on this sort of reasoning, see, for example, A Fortunate Universe, Life in a Fine-Tuned Cosmos by Luke Barnes and Geraint F. Lewis. So on the bare non-design hypothesis, the argument goes, it is just much more likely that there would be a non-life permitting universe. There wouldn't be life permitting conditions because most of the ways the world could be are not life permitting, and the hypothesis doesn't predict the life permitting ones over the other ones. But on the contrary, the design hypothesis predicts, if only weakly, that there would be life permitting conditions. So one potential issue with this concerns how to construe the space of possibilities, which we can talk about these different models, right? Varying the parameters this way and that way. Is the space of possibilities just the consistent, models constructible in that way? I mean, the non-design hypothesis, suppose that it only predicts that the actual world is a logically or metaphysically possible world, which doesn't include a designer. Why then would proponents of fine-tuning focus on universes much like our own in certain physical respects, with only small variations in these physical parameters? Worlds continue universes like that, it seems, comprise a vanishingly small portion of the larger logical or metaphysical space. And concluding that life-permitting worlds are uncommon in the relevant modal space, given how uncommon they are in a vanishingly small region of that space, is, I think, just an obviously hasty generalization. This is a somewhat complicated and important issue, but I'm just going to grant it that it's not an issue here. And I'll just accept the premise that on the bare non-design hypothesis, it just is extraordinarily unlikely that the universe would be life permitting in the above sense. All right. So what about the second premise then? That the design hypothesis more strongly predicts life permitting conditions. Well, if the design hypothesis in question predicts only that the actual world is a logically or metaphysically possible world, which does include a designer, why would this hypothesis favor a life-permitting universe any more than does the non-design hypothesis? I mean, it seems to me that it does not, right? It doesn't tell us anything about what sort of universe this thing is likely to create. Perhaps it's just as likely to create a non-life-permitting universe as any other. And of course, the proponent of the fine-tuning argument is free to offer a more specific design hypothesis on which it is more likely that the actual universe would be life permitting. There are, of course, existing versions of design hypotheses which are already like this. So for simplicity, suppose the hypothesis is as follows. The universe was designed by a designer which is at least somewhat disposed to create a universe which is life permitting. This narrows the logical or metaphysical space to universes with designers of this sort. And life permitting universes are more common in that space than they are for the bare non-design hypothesis. Okay. So seems now that we have a way, or at least have granted the first two premises and the Bayesian inference rule. And so you might think that the argument is sound, right? At least given that the design hypothesis isn't antecedently enormously improbable relative to the non-design hypothesis. Well, I don't think it is so simple. So we have to first verify that third premise, that constraint on the priors. In fact, I think that for hypotheses which satisfy the first two premises, they won't satisfy the third. The third premise will be false. And the idea is that the design hypothesis in question, the one that more strongly predicts life-permitting conditions, narrows down the space of possibilities significantly more than does the corresponding non-design hypothesis, so much so that the fine-tuning data does not in fact support that or any design hypothesis over the bare non-design hypothesis. And so how do we show this? So first assumption, and I'm going to suppose, and I think enormously charitably, that a reasonable prior on the actual world being one at which there is a single universe, and that universe is designed to be equal to a reasonable prior on the actual world being one at which there is a single universe and that universe is not designed. So in other words, probability of single universe and design is equal to probability of single universe and not design. This is our priors before considering the fine-tuning data. For simplicity, I'm going to ignore multiverse options, but I'm going to return to this later. Now, how do the above hypotheses, single universe plus design and single universe without design, compare in terms of how they predict a life-permitting universe? As I said already, I think that they're going to be on a par. Just about any universe that is consistent with the design hypothesis is consistent with the non-design hypothesis, and vice versa. And neither hypothesis seems on its own to predict a life-permitting universe over any others. After all, the bare design hypothesis says nothing about what sort of intentions and creative dispositions and so on that the designer has, except in fact that it designed a single universe. If it did turn out that the bare design hypothesis did somewhat favor life-permitting conditions, my point will still go through, and I'm going to return to this, as I already said, later. Now, we will also suppose the following fact about the conditional probabilities of life-permitting conditions given these hypotheses. And that is going to be that the probability that there would be a life-permitting conditions given that there's a single universe that is designed is about equal to the probability that there would be life-permitting conditions given that there's a single universe that isn't designed. Someone might object at this point to that assumption, but I'm going to I'll return to that later and provide sort of reasons for accepting that. Actually, some of what I've already said might be understood as support for that premise. All right, so just to recap on these two assumptions that I've made so far. One, a prior on the sort of bare design hypothesis. And this, for our purposes, that there's a single universe that is designed, is about equal, and we'll just let it be equal to our prior on the hypothesis that there's a single universe that is not designed. And the second assumption I've made is that the conditional probability that there would be life-permitting conditions, given that sort of bare design hypothesis, there's a single universe that is designed, is equal to or about equal to the conditional probability that there would be life-permitting conditions, given that there's a single universe that is not designed. So those are the two assumptions I've made so far. Now, sort of for reasons already said, these hypotheses will not suit the fine-tuning argument because the fine-tuning data will not at all prefer the bare design hypothesis to the given alternative. The first two premises won't both be true because those conditional probabilities will be the same. Now, at this point, the proponent of fine-tuning might accept what I've said so far, but reject that their favorite design hypothesis is merely this like bare design hypothesis. Instead, their hypothesis is more substantive and either explicitly includes the prediction that a life-permitting universe would be created, with some probability at least, or includes some other attributes of the designer. For example, that it's loving. I think Luke Barnes has said something like this, given which we can infer that a life-permitting universe is at least somewhat more probable than on the bare design hypothesis. Whatever additional theoretical commitments these are, right, they're used to expand on the bare design hypothesis in order to predict the data, at least somewhat more strongly, I'm going to denote them with the label P, right? We can now say that the probability of life-permitting conditions L, given is a single universe plus that is designed plus P, so the probability of L given U and D and P is greater than the probability of L given U and D, and so also greater than the probability of L given U and not D. Okay. Will this suffice now for the fine-tuning argument? After all, it seems that we have two hypotheses, the bare design hypothesis, sorry, the bare non-design hypothesis and the specific design hypothesis, which satisfy the first two premises. At least seems like we've granted that so far. Now, whether the resulting argument is sound will depend on whether the third premise is satisfied. And we can now determine the priors building on the constraints so far laid out. So recall from above that the probability of L given U and D is equal to the probability of L given U and not D. And we can use this to evaluate our prior on U and D and P, right? The initial theoretical commitments of the designer hypothesis. First, we note that the probability of U and P, D and P is equal to the probability of P given U and D multiplied by the probability of U and D. Well, the question is, how likely is P given U and D? We will let probability of U and D, which is equal to the probability of U and not D, equal S, which is less than or equal to 0.5. And the probability of L given U and D is equal to the probability of L given, which is equal to the probability of L given U and not D, is equal to T. We'll let that equal to T, and where T is much less than S, right? The fact that T is much less than S is going to follow from the already assumed fact about fine tuning. Suppose, for example, that P logically entails L, right? In this case, the probability of P given U and D is less than or equal to the probability of L given U and D. And so suppose at best that they're equal. Probability of P given U and D is equal to the probability of L given U and D. In that case, our prior probability of U and D and P will equal the probability of L given U and D multiplied by the probability of U and D will equal TS. And suppose X hypothesize that P entails L, the probability of L given U and D and P equals 1. Given the above constraints, and supposing that L entails U, our prior on L, probability of L will be equal to T times the probability of U. Now, applying Bayes' rule, then, the probability of U and D and P given L will be equal to the probability of L given U and D and P multiplied by the probability of U and D and P divided by the probability of L, which will equal TS divided by T times the probability of U, which will equal S divided by the probability of U. But this is going to do no good for the fine-tuning argument since it's no higher than for the corresponding non-design hypothesis. With the given stipulation, the probability of U and not D given L will equal the probability of L given U and not D multiplied by the probability of U and not D divided by the probability of L, which will equal TS divided by T times the probability of U, which will equal S divided by the probability of U. You would also, with the above assumptions, S will equal the probability of U divided by 2. And so the probability of both hypotheses, given the stipulations and the data, is 1/2. And note that I assumed that L entails U, right? That the existence of life requires the existence of a single universe, but nothing of importance changes if it does not. The posterior on both hypotheses would be smaller by some common factor. But I'm not going to make explicit how that would go here. The point is, while the life-permitting conditions are unlikely, perhaps very unlikely on the bare non-design hypothesis, and likely, or at least not as unlikely, on the specific design hypothesis. In this case, they were certain on the design hypothesis. Because the specific design hypothesis is much stronger, it involves a lot more substantive theoretical commitments. It has a correspondingly lower prior, such that the fact that the actual universe is life-permitting does not favor the design hypothesis over the non-design hypothesis. The problem is that we are comparing a very specific hypothesis, the design hypothesis in mind, with a much weaker one, the sort of bare non-design hypothesis, without taking seriously how they should differ in their priors, right? We're just, people are often willing to grant the some seemingly modest constraint on the priors on these hypotheses, but that constraint is in fact not modest at all, and in fact should be rejected. And its rejection follows from the assumptions that I've made here. Okay. Now, the proponents of fine-tuning might say, Well, but my hypothesis doesn't have to be something which entails L. It doesn't have to be something which requires that the universe is life permitting it. It could be something weaker. Okay, suppose that the hypothesis, instead of P, it adds Q, which in conjunction with U and D predicts L with probability P, okay? So that is to say we have conditional probability. The probability of L given U and D and Q is equal to P. Now, given only that our hypothesis predicts L would obtain with probability P, arguably the rational prior on this hypothesis is underdetermined, but if P is greater than or equal to T, then the highest prior we can have will be the probability of U and D and Q is equal to the probability of Q given U and D by the probability of U and D, and we can break up that second probability again, which will equal, and so we would have the probability of U and D and Q is equal to the probability of Q given U and D multiplied by the probability of D given U multiplied by the probability of U, and that will equal to T plus T times 1 minus P divided by P multiplied by the half multiplied by P over probability of U, and that will equal T times the probability of U over 2P. Then, applying Bayes' rule, we will have at most the probability of U and D and Q given L equal to the probability of L given U and D and Q multiplied by the probability of U and D and Q divided by the probability of L, and that will equal P times T times the probability of U divided by 2P divided by T times the probability of U, which will equal 1/2. We do not need to consider the more specific designer hypothesis where P is less than T, since this will be a hypothesis stronger than the bare designer hypothesis, which also predicts life permitting conditions even more weakly. Right, so it's stronger and predicts the data more weakly. So it's just going to be a worse hypothesis, probabilistically. And so it turns out that any design hypothesis will have a posterior here of at most 1/2, regardless the probability of U, and regardless the values for P, Q, and T, since the posterior on the bare non-design hypothesis was 1/2, as we stated above. And so we have shown, given the initial constraints, that the fine-tuning evidence just cannot favor any design hypothesis over the bare non-design hypothesis. So while the sort of calculations here I made were fairly simple, I didn't make them all explicit. And if anyone wants to see a sort of full working out, feel free to stop by the Discord linked in description, and I'd be happy to provide it or explain it. The problem, again, is that because we are comparing a more specific design hypothesis with a less specific bare, like simple non-design hypothesis, while the design hypothesis will more strongly predict the life-permitting universe, it will have a correspondingly lower prior. And if my argument here is correct, its prior will scale down, right, and such that the fine-tuning evidence will not favor it over the alternative. This point might be a little bit unclear. So I want to provide an analogy to get the idea across, and hopefully this will help. So suppose that 2 fair die are rolled, right? The second die lands a 5, and we do not know the outcome of the first. Suppose also that we had the following 2 theories. Theory 1, the first die landed either 1, 2, or 3. Okay, and theory 2, the first die landed either 4, 5, or 6, and the second die landed 5. Okay. Which theory is more likely true? Well, suppose someone made the following argument. Premise 1, given theory 1, the likelihood that the second die would land 5 is low. Given theory 2, the likelihood that the second die would land 5 is high. Premise 3, theory 1 is not antecedently much more likely than theory 2. premise 4, if for some hypotheses A, B, and data C, if the probability of C given A is low and the probability of C given B is high, and the prior likelihood of A is not much higher than for B, then the probability of B given C is greater than the probability of A given C. And so conclusion 5, therefore, given that the second die landed 5, theory 2 is more likely than theory 1. Now, this is clearly an unsound argument. I mean, it has to be unsound, right? Because if it were sound, it would have to be more likely that a fair die would land 4, 5, or 6 than 1, 2, or 3, right? Because if theory 2 is more likely true, then the first die landing 4, 5, or 6 has to be more likely than 1, 2, or 3. But these outcomes are clearly equiprobable. It was stipulated that it's a fair die. But where does the argument go wrong? Right? You might think that all of the premises are correct. Well, it goes wrong precisely where the original fine-tuning argument goes wrong, in the third premise, the constraint on the priors. So let's work through it mathematically. So we have the probability of 5, or F, given theory 1, equals 1/6. And the probability of F given theory 2 is equal to 1, right? Theory 2 entails that the second die lands 5, F. However, our priors on these theories will be, for theory 1, it's going to be a half. And for theory 2, it's going to be a 12th, right? So contrary to the third premise, theory 1 is actually antecedently much more likely than theory 2. A half is much greater than 1/12. Or at least it's greater such that we need to account for it in the argument. We can't just assume that they're kind of similar enough for the difference in conditional probabilities to warrant belief in the second hypothesis. So applying Bayes' rule, we could see that the probability of theory 1 given F is equal to the probability of F given theory 1 multiplied by the probability of theory 1 divided by the probability of F, which will equal a 6 times a half divided by a 6. And that will equal 1/2. And the probability of theory 2 given F will equal probability of F given theory 2 multiplied by the probability of theory 2 divided by the probability of F, which will equal a 12th over a 6th, which will equal a half. The theories come out on a par, conditioning on the data. So as expected, right? Given the data, the theories are on a par, and we cannot infer the first die is more likely to have landed 4, 5, or 6 than 1, 2, or 3. It is exactly the same, I contend, in the fine-tuning case, right? The bare non-design hypothesis, right, that there's a single universe that isn't designed, is like theory 1, and the specific design hypothesis is like theory 2, right? The first die landing 1, 2, or 3 is the analog to there not being a designer, and the first die landing 4, 5, or 6 is the analog to there being a designer. The additional positive theory 2, that the second die lands 5, is the analog to the additional posit we must add to the bare design hypothesis so that it predicts life-permitting conditions more strongly than does the bare non-design hypothesis. But as with the die case, while the theory more strongly predicts the data because of these additional posit, it does have a correspondingly weaker prior, such that the theories will come out on a par, at least with respect to the data under consideration. We are misled, although more easily in the fine-tuning case than the die case, when comparing a non-specific theory to a specific one, because we recognize that the specific one more strongly predicts the data, but fail to recognize that a reasonable prior on the non-specific theory is much higher. Okay. Let's consider some possible objections. 1, setting the priors on the bare design hypothesis to be equal to that on the bare non-design hypothesis is unreasonable. The bare design hypothesis should be antecedently more probable. Well, on the contrary, my choice here was intentionally made to be incredibly charitable to the design hypothesis. I think it actually should be much lower. So although agreeing to priors can be difficult, it seems to me that the non-design hypothesis fares better in terms of ontological simplicity, both in the amount and kind of entities it posits. It does not fare worse as a theory anywhere else, and so at least should not be considered intrinsically less plausible than the bare design hypothesis. So for more on this sort of reasoning, see, for example, Graham Oppy's The Best Argument Against God. At the very least, I think it's at least reasonable to reject that the bare design hypothesis is actually more plausible than the bare non-design hypothesis. Objection 2. But there are other bits of evidence and arguments given which we should have higher confidence in the bare design hypothesis. And so we should consider it actually more plausible than the bare non-design hypothesis. Okay, so even if this is true, it's not going to have any bearing on the extent to which the fact that the universe is life permitting confirms the bare design hypothesis. So, in other words, if we are antecedently more confident in the bare design hypothesis, conditioning on the fact that the universe is life permitting we will subsequently be more confident in the bare design hypothesis over the non-design hypothesis, but we will not be more confident than we were prior, right? If the central point of this video is correct, then the fine-tuning data confers no additional evidence to the bare design hypothesis, even if prior and subsequently we are more confident in the bare design hypothesis. I'm skeptical that the evidence does in fact point this way, but even if it does, my conclusion could still follow. Objection 3. The conditional probability of life permitting conditions on the bare design hypothesis is not approximately on par with the conditional probability of life permitting conditions on the bare non-design hypothesis. Rather, the bare design hypothesis does at least modestly predict life permitting universes. There are 2 points to make here in response to this objection. First, as I said before, I just deny that the bare design hypothesis more strongly predicts life permitting universes. The bare designer hypothesis tells us nothing about the creative intentions or dispositions of the designer, except that it's, in fact, creates a universe. But why would it be disposed to create a life permitting universe over any non-life permitting one? If you want to say something like, well, it would be disposed to create universes like that contain the sort of things like it that are capable of design. Well, why? Why would it have that disposition? That seems to me like a further commitment that we could add to the hypothesis that's not given already in the bare designer hypothesis. And if we want to add something like that in, that is disposed to create at least somewhat, it's at least somewhat disposed to create universes that contain creatures like it, in certain respects, that could be like part of our additional posit P or Q from above. It's not something given in the bare designer hypothesis. Now, accordingly, it does not follow from such a hypothesis that the life permitting universe is more likely to be created than a life prohibiting one. So, second, even if the bare design hypothesis does more strongly predict life permitting universes, I'm going to contend that the hypothesis is thereby not as weak as we might have thought. And so its prior should in fact be lower than for the bare non-design hypothesis. So more, of course, can be said on this issue, but for my purposes here, I'm just gonna leave it at that. Objection 4. But what if I just don't accept your initial priors and conditional probabilities? Here, there's not much more that I can say. I think I've given good reasons sort of for the constraints that I've selected, and I think I've been overly charitable to the design hypothesis. Still, if someone wants to reject these assumptions for some even more favorable to the design hypothesis, I can't stop them, but I think most will agree that my assumptions here have been more than fair, and I would need some additional reason to think otherwise. Okay, objection 5. But what about the multiverse and no universe options? You kind of skipped over those. Might those not change things? The first thing I want to note is that although the multiverse is a common objection to fine-tuning, on my view, it actually sort of completely misses the mark and does not work as a rebuttal, on its own at least. And for simplicity, I avoided multiverse hypotheses here. And this might be a bit hand-wavy, but for my purposes here, I'm just going to say that considering the more general design and non-design hypotheses, which are perhaps consistent with there being either no universe or some vast multiverse, while that would require more work, right? There's more sort of possibilities and different probabilities to calculate. It doesn't result in a substantively different outcome. The same conclusion is drawn from that. So if anyone watching is interested in a follow-up discussion on fine-tuning and multiverses, both on this issue of whether the multiverse might favor the designer hypothesis, or whether the multiverse objection to the fine-tuning is any good, which I think it isn't, I can elaborate there. Objection 6. Wait, something isn't right here. It cannot be that both the bare designer and the bare non-designer hypothesis both very weakly predict life-permitting universes. So it's clearly one of these is true, and the universe is in fact life-permitting. Would we not have to then accept that something very unlikely happened either way? I can maybe understand the intuition behind this concern, but it's just in error, right? Both hypotheses will very weakly predict a wide variety of things. For example, what I'm saying right now. But that's entirely consistent with precisely one of them being true. Okay, objection 7. It seems that your response to fine-tuning has proven too much, since it shows that a more specific theory is never preferable to a less specific one. No, I mean, this is just false. It's true to generate examples consistent with everything I've said here, where we would prefer a more specific hypothesis to a more general one. It's just that this isn't the example, but this isn't one of those cases where a more specific designer hypothesis is preferable to a less specific non-designer one. Okay, objection 8. Well, even if the design hypothesis doesn't come out ahead sort of probabilistically, I still feel like we should accept it, given that it's the best hypothesis we have here. There are at least 2 things to note here. First, I'm not at all convinced that the design hypothesis is the best hypothesis we have, or even a very good one. Second, this response would require giving up on the standard Bayesian fine-tuning argument in favor of some abductive argument, some inference to the best explanation. Since the Bayesian argument was my target of the video, I'm going to take that as an implicit admission that the video satisfied its goal. Objection 9. But the non-design hypothesis seems to require that certain facts are unexplained, while they can be explained on the design hypothesis. Right? Such facts include the fact that the actual parameters take the values that they do rather than other possible values. We can explain that by the designer. The designer made it that way, perhaps because it desired to permit life for many conditions, or was otherwise disposed to create in that way. But on the non-designer hypothesis, you might think that there's just going to be no further explanation for these facts. Well, if this turns out to be the case, and I'm not sure, it's not really obvious that it would, but if it does, then yeah, that's where explanation will run out on the non-design hypothesis. For the design hypothesis, explanation will presumably run out regarding certain facts about the design, that it chose those actual values rather than others, or that it had the creative dispositions that it does rather than others, and so on. Accepting the design hypothesis simply because explanation extends one layer further is, I think, a mistake. Explanation runs out somewhere, right? And we should not always favor some theory just because it posits more and it has a few more layers of explanation without sufficient additional theoretical benefit. So after all, presumably we wouldn't want to conclude that we should prefer a further designer hypothesis, which includes the design of this designer, just because it can explain otherwise unexplained features of the designer, which by the original hypothesis created the universe, right? If I came back to the proponent of fine-tuning and said, oh, but look, I accept, your argument, there is a designer for the universe, but what explains the creative dispositions of that designer? What explains the it having chosen to create a life-permitting universe rather than another? Well, I can posit something else which explains that. We don't want to accept another theory just because it explains something otherwise unexplained in another theory. We would proceed down this, I think, vicious regress of explanation. And nothing here, unless we have good reason to think that these facts should be explained by something, the fact that the parameters take the values that they do rather than others, which doesn't equally apply to the designer in question, I think the proponent of the non-design hypothesis is well within their epistemic rights at rejecting this sort of inference to the designer hypothesis on the basis that it explains these facts. And again, regardless, this response amounts to an abductive claim anyway, right? Which was irrelevant to the success of the Bayesian argument, which I think fails. All right. So this was originally intended to be a fairly short video because the main point, I think, is fairly basic. Fine-tuning fails to support the designer hypothesis because the sort of designer hypothesis which more strongly predicts life-permitting conditions will have a lower prior, correspondingly lower prior, such that it does not come out ahead of the non-design alternative when we condition on the data. We are easily misled, I think, by this sort of argument because we are comparing a non-specific, non-design hypothesis with a more and perhaps very specific design hypothesis without taking seriously how these hypotheses should differ in their prior probabilities. Generally speaking, it is better to compare hypotheses of similar specificity because you don't run into these issues as frequently. To reiterate, here are the sort of notable probabilistic assumptions that I made. One, our prior on the bare design hypothesis is about equal to our prior on the bare non-design hypothesis. And assumption two, the likelihood that there would be a life-permitting universe given the bare design hypothesis is about equal to the likelihood that there would be a life-permitting universe given the bare non-design hypothesis. From these, and given sort of standard Bayesian reasoning, it follows that the standard Bayesian fine-tuning argument fails. If you've made it this far, thanks so much for watching. I hope you got something out of it. I have a feeling you might want to re-listen to parts of it to follow it and maybe think about it for yourself, because it's not the easiest thing to explain relatively succinctly. Feel free to leave any comments of criticism or requests for elaboration on any points in the comments or on the Discord. And thanks to my current patrons, Ninjabem, Josh, Marsbars, Riss, and Joe. If you'd like to join them to support the creation of more content like this and to get early access to videos and some other rewards, check out patreon.com/friction. Otherwise, thanks for watching, subscribing, and I'll see you in the next one. We've got some great stuff coming up.